Let's do another one. Oh, let me go back here. Okay. And let me identify this molecule. Oh, there it is. We have that. All right. So the next one is going to be nitric acid, HNO3. This stuff's powerful stuff. It's used in making explosives. It's also used in making fertilizers as well. But a different kind of aspect of fertilizer than ammonia. So nitrogen is the central atom, hydrogen cannot. So that's your central atom. Put that down first. Nitrogen is in group 5A, so it has 5 valence electrons. North, south, east, west. Pair. And we got 3 oxygens. So I'm going to put an oxygen in there. North, south, east, west. Let's do this. And let's put another one over here. North, south, east, west. There. And I'll put a third one up here. North, south, east, west. There. We have 1 hydrogen. It's going to go on one of these oxygens. I'm going to put it right here. You can put on any one you want. It makes no difference, but you have to use finagling with the electrons if you put it in a certain place. I know it's going to look like something, but hydrogen is the one that gets bonded first. It's the outermost of all the atoms here. So pair this electron up right here. Okay. Now that gives that oxygen 7 electrons. So that needs 1 electron to be full right here for that oxygen. The nitrogen now has 6 electrons. The oxygen now has 6 electrons. We're going to create a double bond using 2 circles for each pair of electrons, 1 pair for each pair of electrons, for a total of 2 circles. This now gives nitrogen 2, 4, 6, 8 electrons. It doesn't want any more, but this does need 2 more. So we're going to move that over there. I'm going to share that pair of electrons with the oxygen. All right? So the resulting structure is going to be oxygen, nitrogen, oxygen, double bond oxygen, and we got hydrogen here, right there. I'm going to put that right there. Pairs of electrons, we've got 2 pairs here. We've got 2 pairs here. I'll leave it where it is this time. And then we got 3 pairs up there on top. Go through, make sure every atom has 8 electrons except hydrogen, which has only 2, which it does. Oxygen 2, 4, 6, 8. Nitrogen 2, 4, 6, 8. Oxygen 2, 4, 6, 8. Oxygen 2, 4, 6, 8. Octet rule satisfied, as well as the dual corollary. Now, this is where the rubber hits the road. How many central atoms do we have here? Well, known as nitrogen is, because that's where all the oxygen are bonded to. And this oxygen right here has 2 atoms bonded to it, so that makes that a central atom. There are no other central atoms, so we don't have to put a 1 for the oxygens to separate from the other oxygens. They will not be figured into the central atom analysis. So central atom here, nitrogen. How many sets of electrons does nitrogen have around it? Well, we got 3 locations where we find electrons, so we have 3 sets. What's the bond angle for 3 sets? 120 degrees. We have 3 bonds, a double and 2 singles. And we have 3 sets and 3 bonds. The geometry then is triangular. Oh, chicken, don't feel like I'm going to go help some cucumber sandwiches at the club. Oxygen here. Oxygen has 4 sets of electrons around it. They have two bonds. Oh, I'm sorry. Automatically that's 109.5 degrees. They have two bonds, the hydrogen and the nitrogen. And when you have four sets and two bonds, it is dancing. And I will tell you this: in oxyacids, any hydrogen-oxygen bond is going to be that set of answers every single time. So you don't have to work too hard for that. Okay? Let's do one more to make sure we got it down, then I will give you your practice problems. The last one is what we call chlorous acid. Chlorous acid. Alright? So, again, this is an oxyacid, which means this hydrogen is going to bond with one of these two oxygens. The temptation is to bond the oxygen or the hydrogen to the chlorine. Don't do it. Chlorine, how many valence electrons does it have? Well, it's in group 7A, so it has 7 valence electrons. Southeast west. Here. Let me put an oxygen here. North, southeast west. There. And then I'm going to put an oxygen right here. North, south, east, west. Here. And then the hydrogen is going to go on one of these two oxygens. Since I have this by a single electron here, I'm going to put the hydrogen here next to the other lone electron of that oxygen. Alright? Start with the hydrogen, outermost electron for our atom first. That's one electron, needs one more to be full, gives that oxygen now 2, 4, 6, 7 electrons. It is now lacking one electron. We'll pair that up. That oxygen now is 8. Chlorine is now 8. Doesn't need any more. Now we get to use the special single bond. We couldn't start out with it because we don't know if we need to or not. We wait until it fills up with 8 before you consider those special single bonds. So this goes over there, and we have that bond right there. And I'm going to draw the linear structure over here. We have twins. Single bond oxygen for this. Single bond oxygen here. And then we got a hydrogen over here. And we got 2 pairs of electrons right there. Okay? So, central atom. Analysis. How many central atoms do we have here? Well, we know the chlorine is 1, so I'll put that down there. And how many oxygens is a central atom? Just that one right there. So again, we don't need to number this one like we did in the first one. So let's go through. Chlorine has 1, 2, 3, 4 locations where electrons are found. That's 4 sets of electrons. That means it's 109.5 degrees. We have 2 bonds on that chlorine. That means it's bent. Oxygen. 1, 2, 3, 4 sets of electrons around it as well. The bond angle then is 109.5 degrees anytime you have 4 sets. Again, we have 2 bonds. And this is going to be bent. So this is one crooked molecule. Everything's bent. Oh my goodness. Can't trust it. Don't give him any money. He's crooked. She's crooked. It's crooked. Whatever. So, that's how you do multiple central atoms decimal problems. Your assignment, or your practice problems, draw the Lewis dot structure, identify all central atoms like I did, the number of sets of electrons, their bond angles, the number of bonds, and their geometries. These 5 compounds. Have fun!